Hi, class. Today our topic is the rational exponent law. Before we dive right into the rational exponent law, let's review a bit of vocabulary. So, very briefly, the rule says if I have x to the power of 1 over n, we get the nth root of x. So, there's a number of things that might not be clear, so let's clarify. The word rational is a description for a number that can be expressed as a fraction. So, numbers that can be expressed as a fraction, this would be like your regular fractions. It could be an improper fraction, and it could even be a whole number. Because if I have a whole number like 8, I could rewrite it as 8 over 1. We know from the last class that when we talk about power, base, and exponents, this is all talking about the power form. So if I have a power such as a to the power of 1 over n, the entire thing here is called a power. We know that the bottom part is called our base, and the top part here is called our exponent, except that in our exponent we have a rational number. Now, on the other hand, it says that our power can be equal to a radical. The whole thing that we have, this is called our radical. The base, which was our a, we call this the radicand. And the denominator of the exponent, it's now placed here, and this is called the index. Okay, so let's take a look at our exponent law. The exponent law itself says that if I have a to the power of m over n, this can be rewritten as the nth index of a to the power of m. Now you'll notice that our base has become the radicand. The numerator of our rational exponent stays as part of the exponent inside the radical. And the biggest difference is the denominator. The denominator of our rational exponent is put as the number for our index. Okay, now that we have all of that vocabulary down pat, let's review some of Pythagorean relation and order of operation to see where this fits in. Now, often in our school system, we learn about bedmiss, but we could consider it breadmiss, where R represents the radical. So remember when you solved for Pythagorean relation? You had a squared plus b squared is equal to c squared, where c was the hypotenuse. So if I were to type this out, I would have 3 squared plus 4 squared is equal to c squared, where c is the hypotenuse. So I simplify, 9 plus 16 is equal to c squared. 25 is equal to c squared. And in order for me to undo the square, we have to apply the square root. So now I have the square root of 25, and this is equal to c. Square root means I want two numbers multiplied together that will give me the radicand, and that would be a 5. So in order for us to take the square, to undo the square, we took the square root. So we could say the opposite of a radical is an exponent. Now you'll notice here in square root of 25, there is no index. So when there's no index, we know that it's referring to a square root. So if it's a square root, it means there's an implied 2 as the index. Okay, if you're using the slides on Desmos, you could use keyboard commands like SQRT once you get into the math type. Alternatively, if you prefer to use the keyboard, you're able to find the square root symbol or the nth root symbol to type it into Desmos. Right, that aside, let's rewrite these powers as radicals. So first of all, let's remember that the denominator always becomes the index. The numerator stays as a fraction, and the m becomes our radicand. So m to the power of 1 over 3 gives us the third root of m to the power of 1. Okay, the next one, 8 to the power of 2 over 3. Our index is a 3, and inside our bracket, we have 8, sorry, inside the radical, I have 8 as the radicand and exponent 2. Now, I'm going to show you that there is another way for us to write it. So we can also write it as the cube root of 8, and all of it is raised to the power of 2. So remember in order of operation, when you do division and multiplication, those two are kind of on the same level. As long as you're going from left to right, it doesn't matter whether you're doing division or multiplication first. And same thing for addition and subtraction. Well, this works also for the radical and the exponent. So you could do the radical first or the exponent first, as long as you're going from left to right. Now, because this is all done in one step, I could say I'd like to simplify the radical and then apply the exponent. Or you could say, I'm going to apply the exponent and then solve the radical. Now, this is going the other way around. We are given two radicals, and we would like to have this rewritten as a power. So, third root of x to the power of 7. The base is going to be an x, and we have the power of 7 over 3. Part B, square root of 6 to the power of 3. Now remember, we said that when we have a square root, it is implied that the index is 2. So when we rewrite it, we have base 6 to the power of 3 over 2. Right, I'm going to give you a moment to try these on your own. Please pause the video, do these questions, and then we'll take it up in a sec. Okay, I take that you've done it. So let's take these up. 8 to the power of 2 over 3. This gives us the third root of 8 to the power of 2. 16 to the power of 3 over 2. This would be the square root of 16 to the power of 3. Now, writing it the other way around, when I have the fifth root of 32 to the power of 4, we could say this is equivalent to 32 to the power of 4 over 5. And in this question, square root of 25 to the power of 3, as a power form, the square root has the 2 in the index, so we would have 25 to the power of 3 over 2. In this lesson, we are going to be doing radicals and simplifying them by hand, but sometimes you're going to be asked to do it by calculator. So I'm going to show you today. I know some people use a handheld calculator, some people use a scientific calculator on the phone, and some people use the Desmos app. For the sake of this course, I am going to try to integrate the scientific calculator into all of my slide set. So I would personally prefer that you use a Desmos app or a handheld calculator. The phone scientific calculator, the one that comes with your phone, is usually a bit difficult to use. So download the Desmos app instead, and you can just type things in the way it looks. Okay, so consider the question. If you have 98 to the power of 2 over 3, you can type it in as an exponent. So if you were to type it in as an exponent, you would have 98 to the power of bracket 2 over 3, so that your calculator understands that this entire thing is your exponent. If you're going to calculate it as a radical, make sure you have the third root and then 98 to the power of 2. Right, so I'm going to show this to you using our scientific calculator here. If I have 10 to the power of 2/3, I'm going to type in 10, use AB, or if I'm using keyboard commands, Shift 6 to pop us up into the exponent, and then type 2 over 3. So that gives us 4.64158, so on and so forth. Now, if you're typing a radical form in the scientific calculator for this course, you would need to type in nth root, which gives you an option to put in the index. And then we're going to put 1 over 2 all to the power of 3. So I like the Desmos calculator because it's very simple to type in the way it looks like and your calculator understands it. Sometimes when you're using the phone calculator, it is very strict about order of operation. So if you type it in the way it looks, it doesn't really work out. We're going to be solving rational exponents by hand. Now, before we do that, we need to simplify a lot of the um, bases that we have, either by using prime factorization or somehow combining our base so that it can be expressed as a power with a smaller base. So let's look at this one. If I had the number 32, I can use a factor tree to create the prime factors for 32. So when I say prime factors, I mean expressing it as a multiple where it's only multiplying by prime numbers. A prime number is a number that has no multiples other than itself, like 2, 3, 5, 7. I mean, look at 11. The only thing that multiplies to 11 is 1 times itself, 1 times 11. There's nothing else that will multiply to give you 11. So let's create a factor tree. 2 times 16 is equal to 32. 2 is a prime, 16 is not. 16 can be rewritten as 4 times 4, and 4s can be rewritten as 2 times 2. So at the end of each of our branches for the tree, I have all the prime numbers. So what I've learned is that 32 is equivalent to 2 to the power of 5. Let's do two more examples just to make sure we are good with factor trees. Okay, so 625. We can rewrite 625 as 5 times 125. 125 can be written as 5 times 25, and 25 can be rewritten as 5 times 5. So we've got 4 5s multiplied together. So 625 is equal to 5 to the power of 4. Okay, part 3, or example 3. If I have the 8, 8 is simplified into 2 times 4, and 4 is 2 times 2. So 8 is equivalent to 2 to the power of 3. Now this will help us solve a lot of rational exponents because we've expressed it as powers with smaller bases. I have 8 to the power of 2/3. First, I'm going to change this into radical form. So we have third root of 8 to the power of 2. I'm going to rewrite 8 as a power with a smaller base. Now remember we said that 8 is equal to 2 to the power of 3. And that's what I mean. I'm going to rewrite the base or the radicand 8 as a power. So now I have the third root of 2 to the power of 3, all of it raised to the power of 2. I'm going to simplify this. Using my power rule, I have 2 to the power of 6. Let's rewrite this as a power form again and simplify. So we have 2 to the power of 6 divided by 3, and that's equal to 2 to the power of 2. So our final answer, 2 to the power of 2. Let's do the same thing for this question. 32 to the power of 3 over 5. As a radical form, I have the fifth root of 32, and it's raised to the power of 3. Now, I've rewritten it this way. Remember, we said that we could do the radical first or we could do the exponent first. I'm doing it this way because this will simplify um, quickly, and we will be raising it to the power of 3 afterwards. So I have 32 is equal to 2 to the power of 5, and all of that is raised to the power of 3. Now take a look here. If I have the fifth root of 2 to the power of 5, this is equivalent to 2 to the power of 5 over 5, which means I have 2 to the power of 1, or simply I am just left with the radicand. So I chose to do that this way because that simplifies my life quite a bit. This entire bracket is 2 to the power of 1, or simply 2, and it's raised to the power of 3. So we could either rewrite it and then simplify, or we could simplify the radical first and then get the final answer. Same thing, you can choose whichever way works for you. Let's do another few examples. So we have 27. Let's do the prime factorization of that so we know what 27 is equal to. So I have 3 times 9 and 3 times 3. 27 is equal to 3 to the power of 3. Okay, let's first rewrite this as a radical. Third root of 27 all to the power of 2. We have the third root of 3 to the power of 3 all to the power of 2. Okay, let's simplify. Third root of 3 to the power of 6. And then when we make it into a power form again, we have 3 to the power of 6 over 3, and that simplifies to 3 to the power of 2. Now, remember we said the other way we could do it? Let's write it first as a radical. So we have third root of 27, and all of that is raised to the power of 2. So we have the third root of 3 to the power of 3, all raised to the power of 2. Now remember we said that when we have the index the same as our exponent, this would divide itself out. So I now have base 3 left and raised to the power of 2. 16. Let's prime factorize 16. 2 times 8, and we know that 8 is equal to 2 times 2 times 2. So 16 is equal to 2 to the 4. Let's rewrite this question. I have the fourth root of 16 raised to the power of 3. Now, because I know that 16 is equal to 2 to the power of 4, and I also notice that the index is 4, I'm going to simplify that first. So the fourth root of 2 to the power of 4, close the bracket, and then raise it to 3. So 2 to the power of 4, and all of that is under the fourth root. That gives us base 2 raised to the power of 3.